In this video, we will be solving radical equations. And to do that, we are going to isolate the radical first. And then if it's a square root, we're going to get rid of the radical by squaring both sides. If it's a cube root, we can cube both sides. Or say we had a fourth root, we could raise both sides by the fourth power to cancel a fourth root. But first we need to get the radical all by itself. So in this first example, I'm going to subtract 5 from both sides. And then I get the square root of 5 minus 2x equals 7. Now that I've isolated my radical expression, I'm going to square both sides to cancel out the radical. So the square cancels the square root. And we get 5 minus 2x equals 7 squared, which is 49. And now I continue solving by isolating x. So I subtract 5 from both sides, and I get negative 2x equals 44. Divide both sides by negative 2, and x equals negative 22. Now, radical equations are prone to extraneous solutions, so we always want to check for extraneous solutions. And we do that by plugging our solution into the original equation and making sure that the solution satisfies the equation. So the square root of 5 minus 2 times negative 22 plus 5, and I'm checking to see if I get 12. Inside the radical, I get 5 plus 44, and that's the square root of 49 plus 5. The square root of 49 is 7 plus 5. I do get 12. So my solution satisfies my equation, and that means that that is the correct answer. In this next example, we have a cube root, but we tackle it the same way. First, we want to get the radical expression by itself, so I'm going to add 4 to both sides. And we get the cube root of 13x minus 1 equals 4. And to cancel a cube root, I raise both sides to the third power. That cancels my cube root, and I get 13x minus 1 equals 4 to the third power, which is 4 times 4 times 4, 64. And then I continue solving for x. Add 1 to both sides. 13x equals 65. Divide both sides by 13, and x equals 5. But again, let's check and make sure our answer works. The cube root of 13 times 5 minus 1 with a minus 4 on the outside, and I hope I get 0. So that would be the cube root of 65 minus 1 with a minus 4 on the outside, which is the cube root of 64 minus 4. And the cube root of 64 is 4 minus 4, which is 0, so it worked, and that is a valid solution. And these next few examples are radical equations are in rational exponent form, where the exponents are fractions. Remember that the nth root of x is actually x to the 1 over n power. So when we have a fraction exponent, the denominator of that fraction is the index of the radical. Or if we had x to the m and the nth root of that, that would be the same as x to the m over n, where m is the exponent, the top of the fraction, and n, the index of the radical, is the denominator of the fraction. So when we solve an equation with a fraction exponent, we use the reciprocal power to cancel out that fraction exponent. So if I were trying to solve x to the 3/2 equals 8, I could raise both sides to the 2/3 power. And the reason this works is because 3 over 2 times 2 over 3 is just 1. When we multiply our exponents, those reciprocals cancel each other out, leaving us with x equals 8 to the 2/3. But 8 to the 2/3 can be simplified. That's the cube root of 8 squared. And I could write the squared on the inside, or I could write the cube root of 8 with the square on the outside. Either way, I get, well, this would be the cube root of 64, which is 4. Or if I do it this way, I get the cube root of 8 is 2 squared, which is then 4. So either way, I get the same thing. Okay, so let's jump into 2a. I'm going to isolate the expression with the fraction exponent first by adding 4 to both sides. And we get x minus 2 to the 2/3 equals 9. And now I raise both sides to the reciprocal power. So the reciprocal of 2/3 is 3 over 2. And those exponents cancel each other out, leaving me with just x minus 2 on the left. And on the right, I need to simplify 9 to the 3/2. Well, since I have a 2 in the denominator, I use a square root, and 9 to the 3rd power. Now, 9 to the 3rd power is a big number, so it might be easier to square root the 9 first and then raise it to the 3rd power and put that exponent on the outside. The square root of 9 is 3, and 3 to the 3rd is 27. So we end up with x minus 2 equals 27. Now I add 2 to both sides, and we get x equals 27 plus 2, which is 29. And again, we should check our answer. So to check, we do 29 minus 2 to the 2/3 minus 4, and we check to see if we get 5. That would be 27 to the 2/3 minus 4, which is the cube root of 27 squared minus 4. The cube root of 27 is 3 squared minus 4. 9 minus 4 is 5. So it worked. This is the right answer. You could also plug this expression in your calculator to check if you want. Okay, in the next example, same idea. First, we need to get x to the 3/4 by itself, though. So we've got to get rid of that 2. So we're going to divide both sides by 2 first. And we get x to the 3/4 equals 8. Now I raise both sides to the reciprocal power, which is the 4/3 power. And we get x equals, well, this is going to be the cube root of 8 to the 4th, and I'm going to put the 4th power on the outside again, so I cube root first and then raise to the 4th power. The cube root of 8 is 2, to the 4th is 16, so we end up with x equals 16, and let's check that real quick. 2 times 16 to the 3/4. We're going to check and see if we do get 16. That would be 2 times the 4th root of 16 cubed, which is, well, the 4th root of 16 is 2, because 2 to the 4th is 16. 2 cubed is 8. 2 times 8 is 16. So it worked. These next examples have an x on the outside. which makes it a little more complicated. But we're still going to solve this by getting the radical by itself first. So I'm going to add the 5 to both sides, and I end up with the square root of x plus 7 equals x plus 5. And now to cancel my square root, I'm going to square both sides. So I end up with x plus 7 on the left, because the square root and the square cancel. But on the right, remember we can't just square both things inside the parentheses. I have to write that binomial twice and use the distributive property, or FOIL. So we get x plus 7 equals x squared plus 5x plus 5x plus 25, which simplifies to x squared plus 10x plus 25 if we combine like terms. Now this is a quadratic equation because it has x squared, so I'm going to try to solve it by factoring. And to do that, I need to move all the terms to one side and get 0 on one side. So I'm going to subtract the x and subtract the 7 from both sides. And that gives me 0 equals x squared plus 9x plus 18. And now I'm going to try to factor that. And I need two numbers that multiply to 18 and add to 9. And I think 6 and 3 should work. So plus 6 plus 3. And then the solutions to my equation would be -6 and -3. But we really need to check and make sure they actually work. So let's check. The square root of -6 plus 7 minus 5, does that equal -6? Well, this is the square root of 1 minus 5, and that's 1 minus 5, which is -4. But I was supposed to get -6, so that one did not work. And this is an extraneous solution. So -6, I cross it off as a solution, it didn't work. And then I'm also going to check -3 to see if that one works. So the square root of -3 plus 7 minus 5, does that equal -3? Well, this is the square root of 4 minus 5, which is 2 minus 5, and that does equal -3. So that one worked. And so our only solution is -3. And this is an example of why it's so important to check your solutions when we solve radical equations. Because even though we didn't do anything wrong, we got an answer that didn't work. Okay, why don't you try the next one on your own, pause the video and give it a shot, and then unpause and check your solution. Hopefully you tried this one on your own. There's the solution. We got two answers, 0 and 3, and they both worked this time. These next examples have multiple square roots. So we still want to solve these by isolating a square root, but which one do we isolate first? Well, my advice is to isolate the one that's slightly more complex first. So in this first example, I'm going to isolate the square root of x plus 9 first. So I'll do that by adding the square root of x to both sides. And I get the square root of x plus 9 equals the square root of x plus 1. So the square root of x plus 9 is now by itself. I'm going to square both sides. And on the right side, I need to put parentheses. And I have to multiply that binomial by itself again. So on the left, we do just get x plus 9. That radical goes away. But on the right, we're going to do the square root of x plus 1 times the square root of x plus 1. And so the square root of x times the square root of x, that would be the square root of x squared, which is just x. The square root of x times 1 is the square root of x. 1 times the square root of x is also the square root of x, and 1 times 1 is 1. These middle terms are like terms, so they can be combined, and we get x plus 9 equals x plus 2 square root of x plus 1. Now, I want to isolate the square root that I have left, which is the square root of x. So I'm going to subtract x from both sides, which actually cancels x on both sides. And I'm going to subtract 1 from both sides, which gives me 8 equals 2 times the square root of x. Now to isolate the square root of x, I divide both sides by 2. And we get 4 equals the square root of x. Now I square both sides to cancel the square root, and we get 16 equals x. But of course, we better check our answer. So the square root of 16 plus 9 minus the square root of 16, does that equal 1? This is the square root of 25 minus 4, or 5 minus 4, which is 1, so that worked, and our answer is 16. For this next one, I want you to pause the video, try it yourself, and then check your solution when you're ready. Okay, hopefully you've had a chance to try that on your own. There's the solution. Check your work. I got 2 answers, 0 and 8. But 0 didn't work when I checked it, so it was an extraneous solution, and the only solution would be 8.